G, and I am going to be going over this Module 2, problem number 13 out of the problem sets. And this is about the amount of time adults spend watching TV, and this is closely monitored to determine advertising pricing for commercials. So the first thing it asks is, do you think the variable weekly time spent watching TV would be normally distributed? If not, what shape would you expect the variable to have? And then I answered this, the variable weekly time spent watching television is likely skewed right, not normally distributed. And that's because you can't go below 0 hours. So you would have a tail to the right on the distribution and not to the left. It would just stop. You know, they can't watch negative hours of TV. So, and then for part B, according to a certain survey, adults spend 2.45 hours per day watching television on a weekday. Assume that the standard deviation for time spent watching television on a weekday is 1.93 hours. So if a random sample of 60 adults is obtained, describe the sampling distribution of X bar, which is the mean amount of time spent watching television on a weekday. So the first thing, X bar is approximately normal. It's not entirely that perfect bell-shaped curve, but many times in life things aren't perfect, and it's no different with statistics. So and then here, this is the sample mean, and that is 2.45, so that's the same as the actual mean that they have, and so those two are the same. And then we have to calculate the sample standard deviation. So what we do here is we take the mean, 2.45, and divide it by, I'm sorry, we take the standard deviation, which is 1.93 hours, and then divide that by the sample size, which is, my calculator is messing up on me, 1.93, so the standard deviation divided by, and then we take 60, take the square root, and then that equals 0.249162 when we round to the 6th decimal place as needed. So let me scoot this over this way. So now for part C, we're asked to determine the probability that a random sample of 60 adults results in a mean time watching television on a weekday of between 2 and 3 hours. So here we have, we need to find this probability. So what we can do is go into StatCrunch. And let's see. Okay. And then here, once we're in StatCrunch, well, we want to find out, let me see, the mean time of watching television between 2 and 3 hours. So here we're going to use the between, and this is going to be give us the probability. So it's going to be between, probability of it being between 2 and 3 hours. Okay, and now the mean we know is 2.45, and then our standard deviation is right here. So 2.45 hours is the mean, and then the standard deviation, 0.249162. And then this will calculate it for us automatically. So here is the actual mean, and that's, of course, in the middle, and that's the overall average, and then between 2 and 3 hours, and then here is our probability that that happens, and that's this area under the curve. So you can see it's most of the area under the curve. So we just put that in, that probability is very high. It's 0.9509. And I rounded to the nearest, rounded to the fourth decimal place. And then the next thing that we're going to look at is one consequence for Part D of the popularity of the internet is that it is thought to reduce television watching. Suppose that a random sample of 55 individuals who consider themselves to be avid internet users results in a mean time of 2.08 hours watching television on a weekday. So determine the likelihood of obtaining a sample mean of 2.08 hours or less from a population whose mean is presumed to be 2.45 hours. So we're using this mean and this standard deviation, but we're going to have to calculate the standard deviation for the sample. So here what we can do is, let's go ahead and calculate the sample standard deviation by doing 1.93, which is the standard deviation, and then we're going to divide it by the square root of the sample size. So divide it by, and then the sample size is 55, and then I have to click this to square root the 55, to take the square root of it, and then I click equals. Your calculator may work differently. This is how the calculator on this my PC works. So now we have the sample standard deviation, and then what I'm going to do is open back up. Oops. Let me see. I need this too. Okay, so, and then we're just looking at, in the question, it's just asking us for what is, let's see. We're looking for 2.08 hours or less. So here, we're not doing a between, we're doing the probability that it's 2.08 hours or less. So we have the less than sign here, and then the mean is 2.45, and then I just calculated out that standard deviation, so let me put it back up. It keeps disappearing for me, so let me put it over here. You won't be able to see it, but I'm just typing that one in here. So 0.260241. Okay, and then I'm going to compute it. And then here, this is our probability. You can see it's small, it's in the tail. So that that number is right here. The likelihood or the probability is 0.0775. So then we look at, let me minimize this. We look at interpret this probability. Select the correct choice below and fill in the answer box within your choice. So I picked if 1,000 different random samples of size n equals 55 individuals from a population whose mean is assumed to be 2.45 hours is obtained, we would expect a sample mean of 2.08 or less in about 78 of the samples. So I filled in 78, and how did I get that number? I took this probability of this occurring, that the people would watch 2.08 hours or less time, and and I found that that probability is 0.0775. So I times it by 1,000, because those 1,000 random samples times that would give me how many. So about 78. So I got really 77.5, and I rounded it up to 78 of the samples. And then this last part, based on the result obtained, do you think avid internet users watch less television? So I don't, because, and you can see I got it wrong, but when you think about it, so 1,000 different samples, and we're only seeing 78 that watched 2.08 hours or less. So no, it doesn't seem like these internet users watch less television. So I hope this helps, and feel free to email me if you have any questions, and thank you so much for